This last subject that we are studying is actually about two subtopics. So this first subtopic in chemistry is organic chemistry. Now, this topic actually has its own complete field, which, us all subtopics in chemistry that you learn in general chemistry do. But you have probably heard some horror stories about organic chemistry from other students or just other professors, or from whatever source you heard it from. And you may have seen memes at this point. I know a lot of science students just end up finding or encountering, science memes or chemistry memes. And a lot of what organic chemistry looks like, especially after you are actually in it and have experienced it, you start to realize, am I just drawing a bunch of hexagons in this class? And you may realize very soon that a lot of what you're drawing seems like just squiggly lines. So this, on top of, the reputation organic chemistry has, leads to people asking or just thinking that organic chemistry is hard. So do I think organic chemistry is hard? In a way, yes, but not because I think students just don't know how to learn it and it's their fault. I don't think that at all. I think it's because many students forget the basics and a lot of professors aren't willing to, just sit down for a class or two and address this gap. So this is one of the memes, and I'm just going like a little bit off topic, but this is one of the memes that I always see. Organic chemistry makes some people cry. So yeah, that's again part of the reputation. So, but back to what the point I'm trying to make is that I don't think it is completely impossible for students to do well at organic chemistry, or you do not have to be this, person who spends 24/7 studying for organic to do well. I think you need to go back to the basics to see what you really don't understand, and then you can address whatever you're learning. So you might have heard my cat meow in the background. Sorry about that. Um, so what we're going to start off first is revisiting Lewis structures. So Lewis structures are what I think personally, what students could brush up on or what could be addressed first by professors that would really help students in this class. The reason for that is because a lot, and the foundation of organic is you being able to draw structures or you being able to look at structures and determine things from this. When students don't even know how to draw them or they forgot some rules about drawing Lewis structures, this is where the problems start kind of layering on top of each other, right? And then you end up kind of in this hole where you can't really dig yourself out of because you don't even know what you don't know, right? So we are going to just start from that. So this is like a review video now using the point of view that you have been through Chem 1, you have been through all of Chem 2, and you will be going into organic or learning about organic. I know some of you students may not even be taking organic. Once you take Chem 2, you're done. But a lot of students do actually take organic as part of a prereq or as part of their degree. So I'm keeping that in mind. So, anybody who's not taking organic after this, you don't have to stress out as much. If you feel okay with Lewis structures, you could probably even skip this video. But if you are taking organic later on, I would definitely recommend taking notes on this video and just revisiting it when you need to. So we are going to be writing Lewis structures using the octet rule. So for simple molecules, all we have to do is pair up unpaired electrons on atoms. So some examples here is hydrogen. So something about hydrogen to note is that hydrogen only has a duet around itself. So hydrogen, you will only ever see it with one bond, one single bond. This, in addition to a few other atoms, are exceptions. But for the most part, many atoms, especially the ones in the first two rows on the periodic table, or in the first two periods, they will follow the octet rule, meaning they only want 8 electrons around them. So here we have hydrogen and we have bromine. Both of these symbols are the Lewis symbols. And like I said, I'm kind of going into this with the idea that you have at least visited Lewis symbols and Lewis structures somewhere along the line in Chem 1. So I'm kind of, this is like a crash course of Lewis structures. It's not the full-fledged, step-by-step foundation, where we have to take it slower because you're in Chem 1. So these are the Lewis symbols, and the dots you see represented around them are the valence electrons. So those valence electrons show you how many electrons this neutral atom has before it bonds. And typically, whenever you form a bond, what you will do is kind of put 2 electrons as a pair. So you can see that we put this electron and this electron as a pair. That is now a single covalent bond. Here we have 2 hydrogens, and then we have a sulfur that has 2 single electrons kind of on their own. So they could use another pair, or they could use another electron. If I'm trying to, saying that more clearly, they could use each another electron to form pairs. So what you see here is that these 2 single electrons on these 2 separate hydrogens each form a bond with those electrons on the sulfur. So you have a bond here and then a bond here. So the way this works is that these electrons, so I'm going to erase this, these electrons are being shared, right? So hydrogen has 2 electrons around it, but because they're sharing, you can look at it both ways. Bromine also has 8 electrons around it, so 2, 4, 6, 8, okay? And then same thing happens here. We have nitrogen, just nitrogen, 2 separate nitrogen atoms, and what actually happens to them, or what is occurring with them, is that they have 3 singular atoms. Oh my god, 3 singular electrons, free to bond. So what ends up happening is those 3 pair up, so you end up getting 3 pairs. So what here you have a triple bond, or a triple covalent bond. So you can have a single, you can have a double, and a triple bond. That is the most that you can form. Those are the 3 types of bonds. So for more complicated structures, you have to follow this procedure. On those structures that I just showed, it was pretty simple. You could see right off the bat what electrons can pair up to form a bond, or a double bond, or a triple bond. But for more complicated structures, you will see that you have to go through this process. So we are going to take that step by step once we reach that example. There's not really a point in me just sitting there and reading those guidelines. So I will explain them once we get to an example. Something to note that I think will help you, especially in organic, because you deal with these electrons, oh my god, I'm using electrons and atoms interchangeably in the wrong way, the most wrong way possible. So sorry about that. So because you deal very often in organic chemistry with carbon, hydrogen, nitrogen, oxygen, these are the bonding patterns that these atoms typically form. So I know in this video, I haven't introduced organic chemistry in general just yet. I'm just kind of talking about it in a sense of how you can be successful in it, right? And that is reviewing Lewis structures. So I will go through that in the next video. But for now, this is a preview of that. So you will see a lot of these atoms in that class. Mostly carbon and hydrogen. Like, you will be sick of carbon and hydrogen by the time you finish organic chemistry. But the general bonding patterns that you will typically see at which these atoms are the most, quote unquote happy, that's how I like to say it, is carbon with 4 bonds and 0 lone pairs, nitrogen with 3 bonds and 1 lone pair, oxygen with 2 bonds, 2 lone pairs, and hydrogen and halogens, because those both form the same type of bonding pattern, is 1 bond. Now for hydrogen, remember, you have a duet, so you only have 2 electrons around it. For halogens, so this is hydrogens. For halogens, what you will see is that you will have 1 bond and 3 lone pairs around it. That's typically when it's happiest, okay? And then we have beryllium, which likes to form 2 bonds and 0 lone pairs, boron, 3 bonds and 0 lone pairs. Sometimes in Lewis structures, you will see that the line bonds have lone pairs left off. Just keep that in mind. And these bonding patterns actually come from valence electrons. So I mentioned this earlier, how Lewis symbols, they demonstrate valence electrons, right? So this is showing you, this periodic table is showing you how many valence electrons each group has. So group 1 on the periodic table has 1, group 2, 2, and then we skip over transition metals. So kind of ignore transition metals because those change. They don't have a set number the way that main group elements do. And then we skip to group 13, and you have 3 valence electrons, and so on until we get to the noble gases, which have 8 valence electrons. So notice how, okay, for example, carbon. Carbon is in group 14. It has 4 valence electrons. So in order to make 8, it wants to form 4 bonds. So 4 plus 4, 8. Nitrogen is in group 15, which has 5 valence electrons. Nitrogen wants to form 3 bonds in order to have 8 electrons around it. So it has 5 valence, nitrogen, and in order to form 8 total electrons around it, it's going to form 3 bonds with something, or with, several atoms. So 5 plus 3, 8. So that's where that pattern kind of comes in, that plays along with valence electrons. So now we finally reached the point where we can practice drawing Lewis structures. And this is where we are going to use this procedure that I mentioned. So first, let's start off with this very simple molecule, NO. So for NO, how are we going to approach this? Just follow the procedure. First, you're going to determine total valence electrons. How do we do that? So you can, if you already know the number of valence electrons per atom or per type of atom based on its group, then that's great. If you need that periodic table that I just had on the previous slide, have that with you. So nitrogen, you have 1 nitrogen. This nitrogen has 5 valence electrons. You will see that I denote valence electrons with VE with the little negative charge. The negative charge just signifies electron, which is negatively charged. And V is for valence electron. So we have 5 valence electrons there. And then we have O, 1 oxygen. Oxygen has 6 valence electrons. And notice that we have this plus charge, what do we do with that plus charge? That plus charge means that we are going to remove one electron. For any plus charge, you remove electrons. For any negative charge, you add electrons. And I physically write it out because I think that's better than writing in something like this, minus one electron. That can be very confusing really quick. So I stray away from that and I just physically write out remove one electron. So, once I add everything up, I can just read that and I'm like, okay, let me take one away. So from adding up the electrons, the valence electrons from nitrogen and oxygen, I get 11. And then I see my note telling me to remove one. So I end up with 10 valence electrons. So I have 10 valence electrons to use up in this structure. So I have finished step number 1. Next, we're going to draw the skeleton structure. Central atom will be the least electronegative element. Start by connecting other elements to the central atom with one single bond. So luckily here, we do not have a central atom. Why is that the case? Because, oh, that's so ugly. So the case for that is because we only have 2 elements. If we had more than 2, then we would have a central atom, but because we only have 2, there's no true central atom. You physically, there's no way, right? You only have 2. They can only form one line, right? Okay, so here we kind of have it easy, but we're still going to follow that guideline, and we're going to draw the skeleton structure by just connecting with one single bond. Okay, so we're done with step number 2. So far, let's count up how many electrons we've used. We've used up 1, 2. I like to count the ends of each line, and count 1 on each end so that I know there's 2 electrons in each bond. So far we've used up 2. So you're going to subtract away 2 from your total. So now I only have 8 valence electrons. Obviously you can take off the little notes that you're making. I'm taking it off so that it's clear. So now I have 8 valence electrons left. Where am I going to distribute these? You are going to distribute remaining electrons as lone pairs to complete octet on outside atoms. So here we have 2 outside atoms, right? There's no central atom, so everything's an outside atom. So I'm going to distribute 2, 4, and then 6. And then I have another pair left. That is now 8 that I distributed. So I have used up everything. I have 0 left. So now, because you're done distributing, right, the next step, we go to the next step. It says place remaining electrons on central atom. There is no central atom and we don't have any remaining electrons. So we skip on to the next step. Rearrange electrons on outer atoms to make more bonds with central atom to make octets. So notice how for nitrogen, we only have 2 and 4 electrons around it. For oxygen, we have 2, 4, 6, 8. So oxygen's happy, but nitrogen is not. Nitrogen is like, what did you do? You forgot about me. So what we're going to do is transfer some electrons around so that nitrogen also has 8 electrons around it. So we have to make 2 of these pairs into bonds. So I'm just showing you these arrows so that you kind of have an idea of what's actually going on. So we are transferring 2 of those lone pairs into actual bonds. So imagine that those 2 bonds are the new ones that we're drawing in. And then that's the original. And now all we have left is a lone pair on the oxygen. We have 3 bonds in between nitrogen and oxygen and a lone pair on nitrogen. Now everything has an octet and everything's happy. So nitrogen has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. So everything has 8 around it. That is your Lewis structure. Let me draw it again. So I'm not erasing it. I'm just simply redrawing it because it got messy. So this was our Lewis structure before I drew over it. So this is our final Lewis structure where everything has an octet. We went through all the steps. We totaled all the valence electrons. We made sure to use everything. And that would be your Lewis structure. Next, we're going to do this other example. And actually, now that I'm thinking about it, I think I would rather just do CH4. It's a very similar molecule. And, you know, you're going to, if you actually draw SiH4 out for yourself, you will see, oh, this is very similar. But because we're approaching organic chemistry, and you know, organic chemistry, as I mentioned, has a lot of carbon and hydrogen. That's why I decided to make this last minute switch. So hopefully you're okay with this, but we're going to follow the steps again. I'm going to go a little bit quicker to not make this video super, super long. So first we're going to determine total valence electrons. We have one carbon. That carbon has 4 valence electrons. If you look on your periodic table, that it's part of group 14, which has 4 valence electrons. And then we have 4 hydrogens. Hydrogen has 1 valence electron, so we have 4 times that 1 for each of them. And then that's it, right? And then we can add everything up. So we have 4 and 4. That's a total of 8 valence electrons. So we determine total. We're going to draw our skeleton structure. The central atom will be the least electronegative atom. The least electronegative atom already in the formula is already at the beginning. So that's a dead giveaway that carbon is going to be your central. Also, whenever you have a case like this where you have one type of element and then you have many of the second type, the first one that's, you know, lonely by itself will be the central. So we have carbon as your central, and then we're going to draw our skeleton structure with single bonds to the other elements. Start by connecting other elements to central atom with one single bond. So that's what we just did. Distribute remaining electrons as lone pairs. So what we have to do is total up the electrons we've used. So we used up 2, 4, 6, 8. Notice that we had 8. So we actually used them up. So this is a very simple structure because we already used everything up. So this, you know, we counted that, or we didn't even really need to follow that. So we are actually done with this, and this is the Lewis structure. So remember, think about those bonding patterns I talked about. Carbon likes to have 4 bonds around it, and this is exactly the case that you see. So next, in the next video, we will actually visit and talk about what organic chemistry is and the types of molecules that exist in organic chemistry. So now for a short break and surprise. This is my cat. This is Cookie. I have another cat. Her name is Mama Kitty, but this is my new baby. His name is Cookie. He was the one meowing in the background of all this video. If you were wondering or worried, you're like, what's going on? So yeah, surprise. I'm not gonna show me because I look a mess and I'm sick. But yeah, just a little bit surprise and kind of little break from what you're about to watch in the next videos, because it's a lot. But anyway, yeah, say hi to my Chem 2 students. Okay, he hates me. All right, okay, he's had enough.